So thank you, everyone. So my name is Alice Duo. I'm part of the World Bank, the DIME group. And within that, I'm part of a subgroup that's iConnect for Impact, that looks at the impact of transport and trade investments. So the topic of this talk would be nighttime lights and beyond, and how do we use granular satellite imagery to evaluate transport corridors. So this is work that I do, but I have also many team members on that, and I'm very thankful for their participation in this. So this is going to be an overview of what we do in general, and more like kind of a flavor of what we can do using satellite imagery. So usually for transport corridor, you have like some of the question we ask is like coming from the intervention, so constructing and upgrading a road or a highway. What are the intermediate outcome we're interested in? Usually it's measuring accessibility, travel time, and things like that, but also urbanization and change in land use related to the road investments. And we're also interested usually in wider economic benefits. So what are the economic spillovers? Do roads leads to an increase in economic activity? The big advantage of geospatial data is that as the transport corridor are huge investments, sometimes covering an entire country, it's very unlikely that we can collect data to do a survey, for example, of participants along those roads and along other roads in the country. So geospatial data gives us less time and labor intensive solutions, but also less costly. It provides us with like kind of a geographic coverage and the granularity we need to do this impact evaluation. And often it has like a higher frequency than what we could have done if relying on survey. So during this very short talk, I would like to cover two things. One is the geospatial data as used in the case of an impact evaluation that is ongoing in Ethiopia. And the other one is the approach we use in order to evaluate economic corridors in Pakistan. So in Ethiopia, we're going to really focus on economic activity and urbanization, and its linked with new transport infrastructure. In Pakistan, we're going to try to see what we can say about not only economic activity, but also about household income. So the Ethiopia's major road program was the Road Sector Development Program. It has been covered by many other researchers. And it was started in 1996 and shifted a bit of perspective along its life cycle from like building federal roads, so big highways, to more local roads. But the idea was to allow Ethiopia to better connect the rural areas to the cities and also develop manufacturing. So, yep. So for that, we're going to look at two things. One is using nighttime light, and it's the data from the DMSP OLS, the older data set for nighttime light, provided by the National Oceanic and Atmospheric Administration, that is available from 1992 to 2013 annually. And other researchers have shown that this is a good measure for local economic activity. It captures quite well the changes in subnational income, and it correlates well with the levels of asset wealth. The other element we can use, and in order to talk about urbanization this time, is using the globe cover dataset that is produced by the European Space Agency. It's very granular, it's 300-meter resolution, and it's a very long-term series. It's from 1992 to 2018. It classifies the satellite imagery in multiple color and layers into kind of land use classes. For example, the blue on this map is water bodies. Red is urban areas. Yellow is agricultural areas. And so again, if we think about what can be the impact of the roads on change in land use and economic activity, we might imagine, and that was the reasoning of the government of Ethiopia, that the agricultural area will become more specialized in agriculture, and there will be some kind of development of manufacturing areas that will be classified as urban. So the result of a event study, and I will skip through the methods, but the result of, if we just look at what's happening over time, those are graphs that present at time zero the moment where a road opened next to a cell, and the year after, so 5 till 10 years after. And what we see is for most roads, which is like all roads pool, no matter what the speed is, we do see a kind of a pickup of urbanization in the year after the road opened. We can also measure urbanization with nighttime light. And by that, we classify nighttime light above a certain level as indicating that we are in an urban area. And there is a slight pickup in an urbanization as measured by nighttime light for areas that are connected to a road of less than 50 kilometers per hour. And then for the local economic activity, we do see that the program actually happened. Opening a road actually happened while the nighttime light were already increasing, meaning that we have a pre-trend that is not null on the last 5 years before the program. So the second case I wanted to discuss is the case of the Pakistan Economic Corridor. So Pakistan wanted to bridge its infrastructure gap. And for that, invested heavily in the CAREC and CPEC corridor, and the CAREC corridors were supported by DFID and the SDB. So we were primarily, for the impact evaluation per se, interested in 4 segments of roads, but we will also look at, because we have all those data sets available, we also want to look at a wider perspective on that. So we have 2 questions that motivate us. One is like kind of, can we say something about the long and medium trends in transport infrastructure and development? And the second is like, can we go beyond just nighttime light and economic activity? Can we say something about household welfare via income? Okay. So as I said, for impact evaluation of the corridors per se, we could stop there. But actually, the fact that we can combine multiple sources, some are like geospatial imagery, but the other one is also like more traditional sources of digitized road network, for example, and compiling this with historical census and matching and merging those maps. Then we can look at long-term trends and get like perspective on what happened before that. And then we can look at medium trends using like historic and high resolution imagery. Then we can capture recent changes across the network of roads. And by that, we can consolidate an accurate map of the network of roads over time. The last point I wanted to make is the nighttime lights are kind of an imperfect proxy for asset-based wealth index. So some literature shows that nighttime lights capture very well wealth of household. In the context of Pakistan, we wanted to try that. Why? Is because if we can say that nighttime lights are well correlated, then we can go a bit further in our analysis. So we constructed an asset index based on survey data that exists at the district level. So that's kind of medium administrative level. And what we find is that the nighttime light have 30% correlation with the constructed index, meaning that it's not completely off. It's a positive and significant correlation, but it's not kind of one-to-one. And finally, what we've done since is, well, what can we do if we actually have like geocoded household data now? So rather than using average for a district, what can we say about poverty level if we have like points of households? And so doing this, what we did is using geocoded information on households. We train a convoluted neural network to predict nighttime light using daytime imagery now. So as much imagery, satellite imagery as possible, using Landsat and VIIRS. And then we use this feature to train a machine learning model to predict the poverty level or the poverty status of the household using that survey data. And the initial result gives us like 70% accuracy in prediction of the binary measure of poverty. So basically, it's like adding layer on top of layer, we get better and better predictor of household income. So thank you, and thank you to all the teams and all the team members that are involved in this research.